Hello everyone, welcome to my YouTube channel Easy Way to Learn. I am Shailja Tripathi and today's topic of discussion is chemical properties of carbon compounds. So the first chemical property that we are going to discuss is combustion. So combustion means to burn anything in air. And we already know that most of our fuels are carbon based. And these carbon compounds, when they are burnt in air, they produce large amount of heat and light. Hence, we can say these carbon compounds are also good fuel. So, see, carbon compounds when burned in air produces carbon dioxide and water. So, these carbon compounds which we are talking about are basically hydrocarbons, that is they are containing only hydrogen and carbon. So, when they'll burn in air, that is in presence of oxygen that is freely supplied, they will produce carbon dioxide and water. So, these two are the ultimate products that are produced, or we can say these are the final products of complete combustion. So let's see carbon when burnt in oxygen produces carbon dioxide, CO2. So carbon burning in air is producing carbon dioxide. Next, methane, CH4. Let's see the balancing of methane gas, CH4. See, CH4 plus oxygen, it's a hydrocarbon. It will produce only two products, carbon dioxide plus water. So let's balance it. See, here we have 4 hydrogen on the LHS side. So we put here 2. So on the RHS side now we have 2 plus 2, 4 oxygen. So let's make it here 4. 2 2s are 4. Now it is balanced. Next, another important carbon compound is ethanol, CH3, CH2, OH. This is also a very good fuel. This, when burnt in oxygen, will also produce carbon dioxide plus water. Let's balance it. On the LHS side, we have 2 carbons. So let's put here 2. Now hydrogen on the LHS side are 6. So let's make it 6 by putting here 3. Now we have 7 oxygen on the RHS side. So let's make it 3 here. So, so oxygen is also balanced. See, all the atoms on the LHS and RHS sides are balanced. Balancing. Practice it well. Okay. Next important point is that all saturated hydrocarbons burn with blue flame. That is, they in presence of free supply of air, they burn with blue flame. That is, they are clean fuel. But in limited supply of air, this saturated hydrocarbon will also start burning with yellow flame, giving sooty flame, yellow and sooty flame. While unsaturated hydrocarbons always burn with yellow sooty flame. So this example you have observed even in your kitchen, that when gas stoves get blocked by food particles that keep falling while cooking, so the flame, the blue flame is no more coming out because of the blocked air holes. So in insufficient supply of air, it starts giving out yellow flame, and the base of the utensil gets coated with black color, black soot. Next important point is that burning of coal and petroleum emits carbon dioxides of sulfur and nitrogen, which are responsible for acid rain. So coal and petroleum contains these pollutants or the compounds of sulfur and nitrogen. So when they burn, they will obviously produce oxides of sulfur and nitrogen, and which are responsible for acid rain. So this much is for combustion, and these oxides of sulfur and nitrogen are obviously pollutants. Next important property that we have to study is oxidation. Let's see next important property, that is oxidation. See, one must understand that combustion is also oxidation reaction because oxygen is being added to the substrate. So see here, hydrogen is being replaced in case of methane and it is replaced with oxygen. So it is also oxidation reaction. So we can make a statement that combustion is also a oxidation reaction. So why we need to study oxidation separately? This is because combustion will give the final product, that is carbon dioxide and water. If we need to stop the reaction at any stage, then we need some oxidizing agents depending on their strength. So like ethanol, when we did combustion reaction, the final product was carbon dioxide and water. But if we need to stop the reaction at some stage, then comes the use of oxidizing agents. So there are two oxidizing agents that are mentioned in your NCERT book, that is potassium permanganate. This is potassium permanganate. This is like purple color, or it's a purple color crystal dissolved in water. It will give purple to pink shade depending on the amount of water you are adding to make the solution. And another oxidizing agent, that is potassium dichromate, K2Cr2O7. This is orange color crystals. Again, it is dissolved in water to make the solution and used. See, potassium permanganate formula is KMnO4. So you must remember these two oxidizing agents. So how you are going to write the formula? So always remember Cr2O7, 2 negative. This is dichromate ion. Dichromate ion. So dichromate ion with valency 2, and this is MnO4. This is permanganate ion with valency 1. Permanganate. See, the only oxidation reaction that you have to remember for class 10th is oxidation of ethanol. So ethanol, when oxidized in presence of alkaline KMnO4 or acidified potassium dichromate, this will give you acetic acid. So CH3COOH is acetic acid. Acetic acid. Okay. Now see why we are saying that conversion of alcohol to acid is an oxidizing reaction. So we must now understand why this reaction is being called oxidizing. See, if we write the formula CH3 CH2, for simplicity I am writing CH2 in this manner, then OH. See, in presence of these oxidizing agent, what is happening? See, these two H atoms are being removed and they are replaced by single oxygen atom. So, removal of hydrogen or addition of oxygen is called oxidation. So you can show the reaction in this manner, and also you can explain it that two hydrogen atoms are being replaced by single oxygen atom in alcohol. Hence, ethanol is getting converted into ethanoic acid. See, ethanoic acid. Common name is acetic acid or vinegar. And this is two carbon compound having OH, so it is ethanol. So this compound is ethanol. Ethanol. Okay, so once again, let's revise it. Oxidation is addition of oxygen, and basically this addition of oxygen is taking place with the help of some oxidizing agent, and this reaction is taking place in some vessel or in test tube. So it is in situ, that is in the test tube. And addition of oxygen to the reactant is called oxidizing agent, and you have to remember two oxidizing agents, that are acidified potassium dichromate and alkaline potassium permanganate KMnO4. So here you have to remember the formula also. Okay, now the conversion of ethanol to ethanoic acid I have already explained, because it is also asked why this is called oxidation. So you have to write that two hydrogen atoms are replaced by single oxygen atom. So replacement of hydrogen with oxygen is oxidation reaction. Next we come to addition reaction. Let's see addition reaction. See, addition reaction is chief characteristic of unsaturated carbon compounds. So unsaturated means having a double or a triple bond. So hydrogen is added to unsaturated hydrocarbon. So you must remember, it is chief characteristic of addition reaction is chief characteristic. So this question is always asked. Chief characteristic of unsaturated hydrocarbons. Unsaturated hydrocarbons. Okay, why it is shown only by unsaturated hydrocarbons? Reason being, addition means you're adding something without removing something that is present in the original reactant. So it is called addition. But let's see, it can be explained in this manner. See, for simplicity, I am just taking this. So these four places can be written by, you can write R, that is alkyl group, it can be H, or these R can also be replaced by H. So compound may be anything, but the only thing you have to remember, that in presence of catalyst nickel or palladium. So one more catalyst that you have to remember is palladium, that is palladium or nickel. So these are the two catalysts which are helping in addition of hydrogen. See why it is called addition, because out of these four positions which are occupied by the atoms or the group of atoms, they are not being replaced. See, they will remain. The R will be present, H will be present, and see, the tetravalency of carbon is not complete. So hydrogen, if you are taking hydrogen in presence of palladium or nickel, so hydrogen atom will add on to these two carbons. See, now the tetravalency of carbon is complete, and these are two new hydrogen atoms that are added to the compound without replacing any of the atoms present in the original compound. Hence, it's called addition reaction. So there are 2-3 points you must always remember about addition reaction. Firstly, it is chief characteristic of unsaturated compound. Okay, it's not happening. Another important point is it takes place in the presence of catalyst, nickel or palladium. And if hydrogen is being added to the reactant, the reaction is called hydrogenation. So basically this reaction is hydrogenation. See, I'll write it here. Hydrogenation. See, since hydrogen is being added, it is called hydrogenation. Okay, and this reaction is of utmost importance. Reason being, see, saturated fatty acids are basically those that contain single bonds, and unsaturated oils are generally unsaturated, that is they have these double bonds in between them or triple bond between the carbon-carbon chain. So oils can be converted into fats. So fats are saturated and oils are unsaturated. So you can convert vegetable oil into fats. One more thing we must remember, that these fats are not good for health. So why then, what is the logic of converting oil into fat? Well, oils are good for health. So if you consider this as oil and this as fat, which is saturated, you must always remember that it is containing only single bonds. Unsaturated means double or triple bond. So our oils are generally unsaturated, and this is good for health, and saturated fats are not healthy or not good for health, not good. So what is the logic of converting oil into fat? The reason being, it increases the shelf life of the product. So this is the reason that this industrial process is carried out, to increase the shelf life. Next we take substitution reaction. See, now let's see substitution reaction. So substitution reaction is the chief characteristic of saturated hydrocarbons. So this question is often asked, that substitution reaction is shown by what kind of hydrocarbon, that is saturated hydrocarbons. So substitution, as the name suggests, substitution means one or more than one atom of the reactant is replaced by some other atom. For example, you can see in this reaction, hydrogen atoms of methane are replaced by chlorine. So substitution, you must remember that the original product, whatever atom it is containing, it is being replaced. Okay. one more important point, that saturated hydrocarbons, saturated hydrocarbons are very unreactive and inert. So these are inert and unreactive as compared to, if we compare them with the unsaturated compounds. So two things you must always remember about substitution. Firstly, it is shown by saturated hydrocarbons, and saturated hydrocarbons are very inert and unreactive. So they will show very few reactions. And one of the important reaction is addition of, substitution of hydrogen atoms in methane with chlorine atom. See how this is done, or how you will remember. See, CH4, again for simplicity's sake, I am writing hydrogen in this manner. So for organic compounds, or for organic reactions, the only way to remember them is to write them. And in what simple way you can write them with understanding, that will be helpful, and you will be able to recall them in your exams. So the main thing is that under stress, when you are working in during your paper or test, how to recall the reaction. That is the key thing that you must always practice, or key points you must remember while preparing the chapter. See, in presence of chlorine, and the reaction takes place in presence of sunlight. So what happened? See, one of the hydrogen atom will be replaced by chlorine. So this, and I can also write chlorine in this manner, Cl dash Cl. So this one chlorine atom will combine with the hydrogen atom of the methane to form HCl, and the product that is formed is chloromethane. You can write chloromethane. The reaction doesn't stop here, it will proceed further. Next atom of chlorine will come and another product is formed. See, one more hydrogen atom will be replaced by Cl. Again you have HCl. So this is dichloromethane. Dichloromethane. Again, the reaction can continue as long as there are hydrogen atoms present. One by one, hydrogen atoms will be replaced. Now again, trichloro, see 3 chlorine atoms plus HCl. So this is trichloromethane. And this compound is also called chloroform, which is used as anesthesia. Trichloromethane, or commonly it is called chloroform. It is used as anesthesia, for anesthesia. Okay, again the reaction can continue. Cl. Again this hydrogen, last hydrogen will also be replaced. Plus HCl will be formed. So this is tetrachloromethane or carbon tetrachloride, and it is a very good solvent for organic compounds. So this is tetrachloromethane, tetrachloromethane, commonly called carbon tetrachloride. Carbon tetrachloride. It is a very good organic solvent. It means that most of the organic compound will dissolve in this liquid carbon tetrachloride. So we see that in substitution reaction we get different products, and these products are of immense importance, used in for different purposes. Hope you understood the topic well. Please like, share and subscribe. Keep practicing and best of luck for your board exams. Thank you so much.